We present a novel audio-driven facial animation approach that can generate realistic lip-synchronized 3D facial animations from the input audio. Our approach learns Viseme Dynamics from speech videos, produces animator-friendly Viseme curves, and supports multilingual speech inputs. For example,
该技术可以用于提升三维角色面部动画制作的效率，可以很便捷地用于三维数字人、三维游戏、三維動畫番劇等内容的制作。
音声メッセージが既存のウェブサイトを超えたコミュニケーションを実現。
El 2023 se inició con leyes nuevas para muchos. Durante el transcurso del año, 27 estados.
Führende Gesundheitsexperten halten die Corona-Pandemie in Deutschland für überwunden, spätestens nach diesem Winter.
Mes chers compatriotes, pour la 6e fois, j'ai le privilège de partager avec vous ce moment des vœux.
Previous audio-driven facial animation approaches can be categorized into two lines: vertex-based animation and parameter-based animation. Vertex-based animation approaches directly learn mappings from audio to sequences of 3D face models by predicting mesh vertex positions, while parameter-based animation approaches instead generate animation curves to yield animations. Although the former approaches draw increasing attention in recent years, the latter approaches are more suitable for animation production as their results are more controllable and can be integrated into typical animator workflows more conveniently. For example, Jolly defines a state-of-the-art facial rig based on Viseme shapes that can be varied by independently controlling jaw and lip actions. It is widely adopted in game industries due to its artist-friendly design and versatile capability. However, the audio-driven animation of Jolly relies on procedurally generated animation curves, which would sometimes cause a sense of artificial composition and unnatural facial movements. Here is an example.
But, I hope you take a minute out of your busy schedule to listen to this tape, which you just opened up.
The deep learning-based Viseme net trained on Jolly-generated data also has the same problem.
I'm already a burden to my parents, and I'm frightened. I'm already a burden to my parents, and I'm frightened.
In this paper, we propose an approach that employs artist-friendly parameters like Jolly. But instead of procedurally generating the animation curves, our approach learns the animation curves from facial performance videos. Thus our results are more natural and realistic than procedural generation methods. Here are a few comparisons.
Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened. Slow, deep breaths. Your cortisol and adrenaline spiked, but the soft activated your hormone blockers. Nothing happened.
你们真讨厌，吃饱了喝足了就坐那儿看我说话，吃饱了喝足了就坐那儿看我说话，吃饱了喝足了就坐那儿看我说话。
This is my reality, and it is the reality of my people for decades, for centuries. This is my reality, and this is the reality of my people for decades, for centuries.
NBC Glad. Why? Fox TV Jerks Quiz PM. NBC Glad. Why? Fox TV Jerks Quiz PM.
I think we're in a moment of history where probably the most important thing we need to do is to bring the country together, and one of the skills that I bring to bear. I think we're in a moment of history where probably the most important thing we need to do is to bring the country together, and one of the skills that I bring to bear.
The core of our approach is a novel parametric Viseme fitting algorithm that utilizes phoneme priors to extract Viseme parameters from speech videos. The phoneme priors make the extracted Viseme curves better correlate with phonemes, thus more controllable and friendly to animators. More importantly, the Viseme curves extracted from videos are more natural than procedurally generated curves. Here is a comparison.
富人很高兴，给她取名为拇指姑娘。
This would lead to more obvious differences when applying the Viseme curves to new characters.
富人很高兴，给她取名为拇指姑娘。富人很高兴，给她取名为拇指姑娘。
With the correctly extracted Viseme curves from videos, we can train an audio-to-curves mapping using neural networks. In order to support multilingual speech inputs and generalizability to unseen voices, we take advantage of deep audio feature models pre-trained on multiple languages to learn the mapping. Our model achieves the best performances compared to previous approaches, especially when the input audio is distorted in terms of volume, pitch, speed, and noise. We further show that high-fidelity facial animations can be produced with our approach by scanning the static facial Viseme shots of new actors. Here are a few examples. With the acquired Viseme blend shapes, my facial animation is produced from audio. The Viseme dynamics are predicted by our neural network model.
该技术可以用于提升三维角色面部动画制作的效率，可以很便捷地用于三维数字人、三维游戏、三维动画番剧等内容的制作。
音声メッセージが既存のウェブサイトを超えたコミュニケーションを実現。情報に新しい価値を与え、他者との差別化に効果を発揮します。
The approach can also be applied to different facial expressions. For example, the 3 animation clips here are produced from the same Viseme curves, but with Viseme blend shapes in different expressions. Finally, we show more animation results obtained with our approach.
No more than he ate, and not exchange it for an insufficient quantity of more luxurious and expensive things, he would need to cultivate only a few rods of ground.
目で見るだけだったウェブサイトに音声情報をインクルードすることで、情報に新しい価値を与え、他者との差別化に効果を発揮します。
他没有从鹅翅膀上拔过一根羽毛。
I have introduced a speech animation approach that can produce realistic, lip-synchronized, 3D facial animation from audio.
Thanks for watching.